So here we are finding the component form of a vector that represents the velocity of an airplane descending at a speed of 150 miles per hour at an angle of 30 degrees below the westward horizontal. Okay, so if we sketch this out, I never eat soggy waffles. And then we have our airplane that is descending below the westward horizontal at 30 degrees. And this vector has a magnitude of 150 miles per hour. Okay, so you could do this just using 30, 60, 90 triangles, like keeping in mind that you are in the third quadrant. But if we just do it using kind of what I showed on the last slide, where we're going to do the magnitude of the force, and then we're going to have cosine of theta and sine of theta. An important thing to note is that theta here is representing the rotation from the positive x-axis. Okay, so this is just what we've been doing the entire time when we've been doing trig. It's just like your normal rotation versus doing the bearings. So you have to be able to kind of go back and forth between this theta and the theta when we talk about kind of like north 30 degrees west or whatever it is. So in this case, my rotation from the positive x-axis is 210 degrees, right? 180 plus 30. So putting this into component form, the magnitude of my vector is 150. That's the velocity of that vector, times the cosine of 210 times the sine of 210. Okay, so again, you really could do this just using a 30, 60, 90, but this method will work for any angle. So this is 150 times cosine of 210 is negative root 3 over 2. Sine of 210 is negative 1/2. Okay, so the horizontal and vertical components of this vector are, horizontal is negative 75 root 3, and vertical is negative 75.